we got a lot of things going on here thanks to the soybean checkoff and the support we get from the farmers for the checkoff to do research. And there are a lot of different things we're working on. Number one is yield. If we don't have something to yield, you can forget it. But yield is really number one.
Have out here planted?
We've got a lot of different crosses, probably over 1,000 different lines. We're working on a project with the University of Arkansas, Ohio State, and Missouri, all working together on this flooding tolerance. And it's all related to Phytophthora. We're finding out that maybe not major gene resistance, but partial resistance to Phytophthora, at least tolerance, which we call partial resistance, is very important in flooding tolerance. So there's an example of what happens when you don't have, you probably got some other genes for flooding, but also Phytophthora. We're finding out resistance to Phytophthora is very important in flooding resistance. As these acreages, more and more acreages, these clays become under irrigation, that's going to be even more important. About 8 million acres like this of these slowly drained clays. And you can see we flooded these fields and we try to induce a stress to too much water. See, soybeans will grow on clay and they grow well on water. And the thing about it, we've had farmers that get severely, they'll irrigate and they get a big rain and they'll get just clobbered. And it possibly is Phytophthora along with some flooding injury. So we got to try to put good flooding tolerance into these varieties, where a farmer, if he irrigates, then he gets a big rain, you know, he won't receive all that damage.
Yeah.
We've had to go to the germplasm collection, and we're actually screening plant introductions from China, Korea, Japan for resistance to flooding or waterlogging. A lot of our varieties, the reason we're having to do this, we check a lot of the varieties that farmers are growing, especially in group 3s, 4s, and 5s, for tolerance to flooding. But we see some, but not enough. I mean, you'll get some that'll hold up better, but they still get injured. We're looking for one that really will take water. If he gets they're going to hold up better than the varieties they have now. You choose the wrong variety, you can get cut 80% in yield on some of these kind of soils. On a more tolerant variety, you may only get cut like 40%. So, and a lot of farmers know, we've screened a lot of that and we found some that are more tolerant than others. But what we're looking for is something that I don't think we'll get something that'll ever grow in water, but something that'll really hold up if he gets into a severe flooding condition, and then he may not lose anything, or maybe only 10% in a case like this. But you can see the differences, and we've made crosses. We found a PI from Korea, and we found some other PIs, but this is a cross with a Korean PI times a flood susceptible, and you can see that versus that. It's pretty obvious that there's some genes that really will take water. But anyway, I can take that trait, that flood tolerant trait, and put it in something, but it better yield. It's got to yield, a farmer's not going to grow it. We got all these good traits, but it's got to be put into something a farmer can have confidence in. No matter if he gets a Phytophthora problem or he doesn't, he's still going to get very competitive high yield. And yield is the bottom line. A lot of these traits, you don't know if they're carrying bad traits with them, but you got to take the good part of that trait and you put it in there, and that's the key. A farmer, it's got to yield. Yield is number one. Flooding tolerance or Phytophthora resistance with yield is the key. Without it, a farmer's probably not going to grow it.